Hello, here's Ronald Dodd, and today I show you how I use electromagnets to remagnetize this Wrenn Class 4 tank engine. As you see here on the start, at 11 volt DC or even 12, she is not running very well. And for comparison, I show you here the now picture, and in a few seconds after remagnetization, you'll see the after picture. You can see how the locomotive on the after picture clearly is faster under the same voltage. First things first, we have to remove the body from the chassis, and this is easy in this class 4 engines. You just have to remove the front running wheels, and then you can have access to the screw which releases the chassis. Here I have now the chassis running on the track, and that's basically all you have to do in order to dismantle the engine and have access for remagnetization if you prefer to use your old magnets. Electromagnetic sources, I use this 2 copper coils which I have connected, and then I have a central piece in the coil which is basically just iron, which I can use to move the magnetic field. These are then connected to your power supply, and depending on the coil which you're using, you'll get a more or less strong electromagnetic field. This field then remagnetizes the original magnet which is used for your electromagnetic motor. I use 16 volt direct current for my electromagnets. Once switched on, the different poles attract each other. I then position the chassis between the 2 electromagnetic coils, and I have the iron rods directly on the clamps of the magnets. I switch the current on, and you can tell the magnets are strongly adherent. When the current is switched off, the magnets drop off. Obviously, it's important to find the direction of the magnetic field on the magnet which is already on the locomotive. I did this before with a compass. Now, after the first set of remagnetization, I have the impression that the locomotive runs already a bit better, but I'd like to give it another boost. So I turn the electricity up to 32 volt. It can go up higher, up to 40 volt, but I've noticed that the coils get very warm, and I don't want to burn these copper coils. So I remagnetize it again, and as I'm removing the magnets again, you can tell that they're stuck more firmly than before to the motor. Let's give it another boost. Last one today, and this is shorter episodes because it's a stronger field. And they fall off, and we're done with the remagnetization. Now let's put it on the track and see how it runs, especially in comparison with its performance before the remagnetization on the inner smaller circle. It's quite nice how you can tell that the locomotive after all this remagnetization is much faster. All that needs to be done now is to reassemble the locomotive, which is fairly straightforward, and I will not explain this in more detail. Basically, you just have to hook the chassis at the back of the locomotive, and then put the screw back in and put the front running wheels back on again. That's it. And even though this was not done professionally, there is a clearly visible difference between the remagnetized locomotive on the big circle and the small insert of how the locomotive performed before magnetization. I don't have much more to add. I hope you've enjoyed this video, and thanks for watching. Lovely engine, by the way.